Okay, for number 7, now we're dealing with motion problems. And so for these, there's a series of notes that you should be familiar with at the very least and have them written down at the very least so that if this comes up on the AP exam, you can quickly reference your notes. Again, since this is an open note exam, you don't have to commit these to memory as we would normally in the year, but do have all of these written down. So we know S represents our position function. The derivative of the position gives us velocity, and then the derivative of velocity gives us acceleration. We also know that if any time that we're asked about the location of an object, or let's say some guys, it could be like a person is walking along a road. Anytime we're asked about their location, whether they're on the left or on the right or up or down, then we're talking about the position. If we're asked about their motion, for instance, the way they're moving, are they moving to the left or are they moving backwards? Now we're talking about velocity. So anything having to do with motion is velocity. And then if we're talking about speeding up and slowing down, that sort of thing, then we want to look at acceleration. So those are like the key words that tell you whether you're dealing with S, V, or A, position, velocity, acceleration. Let's discuss what their signs mean. So when position equals 0, it means you're at the origin or at the starting point. When position is less than 0, it means you're to the left of the origin. So it's negative, meaning you're in the you're at -5 instead of at 0. It just means that you're on the left, or if you're talking up and down, it means you're below your starting point. If position is greater than 0, then you're on the right. It's positive. If velocity is 0, that means you're at rest. You're not moving. So you are not moving, right? Like your speed is 0. If your velocity is less than 0 or negative, that means you're moving leftward. If velocity is greater than 0, similarly, then you're moving rightward. Finally, if A of t equals 0, it doesn't mean you're not moving. It just means you're not speeding up. You're at a constant speed. If acceleration is less than 0, then it's like there's a force pushing on you in the leftward direction. If acceleration is greater than 0, there's a force pushing on you the rightward direction. Okay, now some more complicated stuff. So we're nearing the end of our explanations here, and then we'll do the problem. But if the question says, when are you moving away from the origin, you need to look at two things. So if this is the origin, if you're on the left of the origin, that means that S is negative. But if you're moving away, then you also need to be moving in the negative direction. So if you're moving away from the origin, you need to have the same sign. So if you're already to the left, you need to be moving to the left. Or if your position is in the positive direction, so you're on the right side, then to move away from the origin, you need to continue moving rightwards. So velocity must also be positive. If you're moving toward the origin, on the other hand, then your position and velocity function will have opposite signs. So for example, if I'm on the left of the origin, so position is negative, then I need to be moving in the rightward direction so that I'm moving towards the origin. Or I could be on the right, so position is positive, but moving towards the origin requires that I'm moving leftward. Therefore, velocity would be negative. Then when we talk about speeding up and slowing down, this is another instance when you need to look at two things at the same time. So if you're speeding up, it means that the way that you're already moving, like your velocity, so let's say you're moving rightward, then you want acceleration to also be positive because it will push you more in the rightward direction. So that will make you speed up. Similarly, if you are moving left and then a force pushes you left, you're going to speed up in the negative direction. So speeding up means that they're going to have the same signs, both plus plus, or they could be minus minus. Slowing down is the other situation. So V and T would have, instead of the same signs, if you're slowing down, they're going to have opposite signs. So for example, V of t is greater than 0 and A of t is less than 0 means that you're moving rightwards, but there is a force that is pushing you to the left. Let's say like a headwind or something, slowing you down if you're a runner, for instance. Okay, so those are our notes. Pause the video, write them all down, or take a screenshot, whatever you need to do. I'm going to erase these and let's do the problem. Great, so number 7 says, here's our velocity function. Identify where the object is slowing down. So immediately, for slowing down, I know I'm dealing with velocity and acceleration. So if I'm slowing down, then they should have opposite signs. Again, no memorization required here. I'm just thinking, okay, if velocity is positive, that means I'm moving to the right. Then if I want to slow down, the force should be pushing me in the other direction, working against me. So acceleration should be negative. It could also be the case that velocity is negative and acceleration is positive. So either way, I need opposite signs. So if I need V and A, and I'm given V, then I should also find the second, or the derivative of V to find A. So I need to find A of t, which is V prime of t, which I'll find using the product rule. Or I could distribute, actually. That would be easier. If I just distributed this, then I know that that's going to be 2t cubed minus t squared, and I can take the derivative of that, which would be 6t squared minus 4t. Okay, so now I have v of t and a of t. What are we doing with them? Well, we want to put them on a number line and compare our signs. So my velocity is 0 at t equals 0 and t equals 1/2. That's where my object is at rest. Now time can't be less than 0, so we're going to cross off that part of the number line. Okay, in the context of the problem, we're dealing with time. It doesn't make sense to have a negative time. So starting on the right side, our number line is positive, and then at 1/2, it flips to be negative, and we don't care what happens at 0 because time can't be negative. Okay, let's do our a of t. So we already took the derivative. Now when we set it equal to 0, we can factor out a 2 and a t. We're left with 3t minus 2. So we see our acceleration equals 0 at 0 and 2/3. I'm going to line up my number lines here. And then 2/3 is greater than 1/2. It's like 0.66. Starting on the right side, we're positive, and then at 2/3, we will flip. We don't care what happens at 0. And now I need to see where V and A have opposite signs. So I'm going to connect these little number lines. Actually, first let's extend our negative and our positives. Okay, and I want to know where these guys have opposite signs, so we're connecting our number lines briefly. Great. So from 0 to 1/2, in this region, notice that our number lines have the same sign. So actually what's happening here is our particle is speeding up leftwards. But between 1/2 and 2/3, our particle is moving to the right, but it's being pushed to the left, so it's slowing down. So we would say object slows, or it's slowing down on 1/2 to 2/3, since V of t and A of t, which is V prime of t, have opposite signs. And then again, notice that this region doesn't work for us because they have the same signs. So in this case, our particle's moving to the right because V is greater than 0, and it's also being pushed to the right because acceleration is positive as well. So our only answer is this highlighted interval here.